Best way to do it.
See if we can get
Okay,
Finish
it's recording.
Okay,
Dave.
great. And what I'm going to do is I'm going to mute myself so I don't make any noises, and then go ahead.
They on mute, so down here.
Okay, we're
Everyone
going
else
to
is
be
on
doing
mute.
the radio merit badge today. So first things first, I have a few radios to show you all. A little bit of show and tell. So everybody's familiar with this first one. Everybody has one. It's just your cell phone. Believe it or not, that is a radio. And then
Here it is.
the
Stop.
older folks will definitely recognize this one. This is a Citizens Band radio or CB radio.
Still work?
Thank you, good buddy.
10-4.
Yes, it does still work. It's got to be installed.
What's your
That
20?
is that's the CB radio I usually use in my truck when I got the connections to do it. This right here is just a scanner. This operates on a trunk system, so this actually I have it set up to scan the radio frequencies that the police department, the EMS, and the sheriff's department use, so I can hear what's going on in our county. And then this right here. Can you go ask your mom to, or shut the door? Okay, this is a amateur radio right here. This operates on the 2 meter and 70 centimeter wavelength. It's got a range of, I picked up repeaters from 30 miles away on this thing.
It can contact the ISS.
If conditions are exactly perfect and you have it pointed in the exact right direction at them. I haven't done that so far. Okay. So, the first requirement is to explain what radio is, and discussing some different things. So, radio uses electromagnetic waves that are sent through the air to communicate and send messages between stations. Radio waves are much like light waves, only the radio waves are much longer than the waves we can see as visible light. Radio waves are emitted from an antenna whenever an electric circuit is sent back and forth through the antenna at a very fast rate. Usually many thousands or many millions of back and forth cycles each second. The rate or frequency of the current cycles through the antenna determines the frequency of the radio wave cycles. What you see right here is a comparison of the electromagnetic spectrum of waves, from radio waves to visible light to gamma rays. So radio waves can carry messages in different ways. The radio waves can be turned on and off in patterns, such as Morse code patterns. The on and off patterns of Morse code represents letters, numbers, and punctuation, so that a message can be sent. Radio waves can also change in power, which is amplitude, or frequency to encode the sound picked up by a microphone. A voice or music may be transmitted by radio waves in this way. The way that a message is encoded into a radio wave is called the modulation method or the mode of transportation.
Oh, I've been working on modules in my prep.
Very cool. Okay. So broadcasting is one-way transmission of radio signals for many people to receive and hear all at once, without a radio message coming back to any of these people. The AM and FM radio stations that you may listen to in your car are broadcast stations. And this is an example of a broadcast station, broadcast booth. It's more on the personal side than a industrial size, but this here is a amateur radio station. Hobby radio is usually two-way communication between people using much lower power levels than broadcast radio stations. Amateur radio or ham radio is a hobby radio that people use to communicate with one another in back and forth two-way conversation. Police and fire officers also use two-way communications by radio to stay in touch with one another. And airplanes, boats, and spacecraft also use two-way communications. A call sign is a special name for a radio station that is used to identify the station from all others in its radio transmission. In the U.S., all radio stations that must have a license must also have a call sign. Broadcast stations' call signs are usually 3 or 4 letter names, such as WABC or WGN. Ham radio call signs have different formats that include a number that tells the region of the country in which the station was licensed. For instance, mine is KI5JJS. Yep, there's a example of a... Yes, Leanna.
I was a ham operator at one time. My dad's call letters are KB5WTV. So yeah, letters and numbers.
And this is another example of a amateur station call sign. The photonic alphabet uses special words to identify a call sign letter. Radio communications are sometimes noisy and unclear, so it's got lots of static. Many letters of the alphabet sound familiar, such as C, D, E, G, P, T, and Z. To help receiving stations understand a call sign in noisy conditions, a photonic alphabet may be used by transmitting operators. It's actually recommended that you do that. So my call sign in the photonic alphabet would be Kilo Indigo, or India. Kilo India 5 Juliet Juliet Sierra. This is the International Telecommunications Union standard photonic alphabet, which is what the military also uses. So if you're familiar with the military, photonic alphabet is the exact same thing. All right. So, radio waves travel by 3 main methods: line of sight, sky wave reflection, and ground wave. The method of travel or propagation is determined mostly by the frequency of the radio wave. Line of sight, which is these guys right here. Some radio frequencies have very high wave cycle rates or frequency, tend to travel in straight lines without being affected much by the atmosphere. We say these radio frequencies travel line of sight because they travel approximately the same straight line distances as we can see around us. These radio frequencies will travel in straight lines towards the horizon until they are blocked by the curvature of the Earth or by buildings, rocks, mountains, or other obstacles in their path. These frequencies will also travel upward through the atmosphere and into space, never to come back. So in other words, they're not reflected back by the ionosphere. So usually these frequencies cannot be used very well to communicate long distances over the horizon without some kind of relay radio station to repeat these signals in a greater distances, or repeaters. That's what this radio mainly is a line of sight radio. Operating on the 2 meter and 70 centimeter. Very high frequency or UVH signals and their higher frequency cousins, ultra high frequency and even higher microwave frequencies, cycle 30 million times per second or greater. So VHF and higher frequencies usually travel line of sight. So sky wave reflection. Some radio frequencies that are referred to simply as high frequency can be reflected by special layers of the high atmosphere, which is what I was talking about with the ionosphere. The signals are also sometimes called shortwave radio frequencies. The sun's energy creates electrically charged particles called ions in various layers up to 250 miles above Earth. These layers are charged particles, the ionosphere. It can act like a mirror to high-frequency radio signals, bending them back towards the Earth. The Earth itself may reflect the signals back into the sky, where the ionosphere can again bend them earthward. With one or more of these signal bounces or skips between sky and Earth, high-frequency signals can travel over the horizon hundreds or thousands of miles, even propagating all the way around the world when conditions are perfect. These kind of signals become very weak as they travel and bounce, so this is sometimes called weak signal propagation. Ham radio operators often use high-frequency HF frequencies to make radio contacts around the world by skywave reflection. The HF region of radio frequencies is from 3 to 300 million hertz. Radio frequencies lower than the high frequency region, less than 3 hertz, are also commonly reflected by the ionosphere. But the commercial broadcast AM radio band in the U.S. falls into this category, extending as low as 550,000 hertz. This is why you can sometimes receive AM stations from a far greater distances. Now, as you can see in this picture, the broadcasting station is right there in the middle at the British Isle. So the guy sends the operator will send his signal out, and it will hit the ionosphere and then come back down. The skip distance is you're not going to be able to hit it. But anything beyond it, you will be able to. Ground wave here, which we're about to get into, is depicted right there. Okay, ground wave. Radio waves with frequencies lower than 3 megahertz can travel along the Earth's surface for hundreds of miles, hugging the curvature of the Earth. These are called ground waves. The commercial AM broadcast frequencies may propagate by ground wave as well as skywave reflection. And that's it. It's just it hits the ground and then just travels across it. So stations WWV and WWVH are U.S. government radio stations that broadcast precise time and frequency information 24 hours a day, 7 days a week, on several high frequency and lower frequencies. The VVW is located in Fort Collins, Colorado. The WWVH is located in Hawaii. These stations broadcast time signals on the 2.5, 5, 10, 15, and 20 megahertz radio signals. So radio operators can turn into these frequencies to see how well those frequencies are being reflected by the ionosphere. If the signals from them are strong, the ionosphere is reflecting well, and shortwave signals may be easily heard from these locations and perhaps many others. So, DX and local stations. This picture you're looking at is from the ISS. This is a perfect example of the farthest DX station you can actually hit. So DX and local stations. A DX station is a station at a far distance, usually in another country from your own. Local stations are close by and certainly inside the U.S. The term DX is a Morse code shortcut for the word distance. Ham radio operators are commonly interested in making contact with DX stations outside of the U.S. So the FCC is the Federal Communication Commission, the branch of the U.S. government that administers the use of radio frequencies and use of the radio frequencies and the issues radio licenses inside the United States. The ITU is the International Telecommunications Union, which is an agency of the United Nations that helps coordinate radio communications and the use of frequencies among the world's nations and territories. And that is it for number 2. So, this is an example of the radio frequency spectrum. So, up in the top right, you have the 300 kilohertz. Between the 300 kilohertz and 3 megahertz is the AM broadcast frequencies. That is where you're going to have the, that's where AM broadcasts. In the middle, you're going to have your high frequency, which is the 3 megahertz to 30 megahertz. Then the very high frequency, which is the 30 megahertz to 300 megahertz. And then the ultra high frequency is between the 300 megahertz and the 3 gigahertz. Super high frequency, 3 gigahertz to 30 gigahertz. And extra high frequency from 30 gigahertz to 300 gigahertz. And beyond that is the infrared spectrum, visible light, ultraviolet radiation, X-rays, and gamma rays. We're not really worried about that. So there are, let's see, so medium frequencies of 300 kilohertz to 3 megahertz, tend to follow the Earth's surface as ground waves for hundreds of miles, but they may also be reflected from the ionosphere as sky waves. Commercial AM broadcast frequencies and one ham frequency band are found in the medium frequency of the radio spectrum. The one ham frequency is the 160 meter ham frequency, and that's around 1.8 megahertz. The high frequency is 3 megahertz to 30 megahertz, tend to be reflected by the ionosphere as sky waves and may travel thousands of miles around the globe. Many of the shortwave and ham frequency bands are in the high frequency region of the radio spectrum, as well as the citizen band radio frequencies. So a lot of the spectrum is actually used. Aviation uses the very bottom of that spectrum, and then after that you got the 80 meter ham frequency, and then the aviation comes in again between that and shortwave radio. After that you have the 40 meter ham frequencies, and then between that, coming up to near 10 megahertz, is the maritime mobile, which is the frequencies that ships and Coast Guard and all those guys are going to use. Then after that you got shortwave again, and then you got the 30 meter ham frequencies. Then
Yeah.
after that,
Can I ask a question?
yeah,
I seem to recollect that the government is busy selling all these radio frequencies to people. Are they cutting into the ham frequencies, or is there a big bank of unused frequencies that the government still is controlling?
they're not touching. They're not selling off ham frequencies, at least not at this time.
Okay.
I'm sure there's not what they're not doing is not selling off frequencies, but they're assigning specific frequencies in a spectrum for use for private aviation, for military use, for TV broadcast, for radio, and all of that. But as of right now, no, they're not giving away any amateur radio bandwidth or frequencies.
Thank you.
Yeah. Okay. Then we have the 20 meter ham radio, ham frequencies, another shortwave, and then after over 15 megahertz, there is another section for maritime mobile use, and then between about 16, 17 megahertz all the way to about 28. 26, 27 megahertz, that's all ham radio. That's the 15 meter and 12 meter bands. Right before 30 meter, you're going to have the citizens bands spectrum, and that's a very, very small amount of the spectrum. And then to finish it off, we got the 10 meter band. So the high frequency radio spectrum is actually the busiest that you're going to have for radio traffic. So the very high frequencies of 30 megahertz to 300 megahertz travel line of sight as described in requirement 2. The FM radio and television commercial broadcast frequencies are in the VHF region, along with 3 popular ham frequency bands. Police, fire, and aviation frequencies are also found in the VHF region. So that is going to be, if you look at it, you're gonna, the second bracket, or the second one in the middle, and then the second bracket in. In that, you got the 6 meter ham, and then right through that is next to that is going to be the TV broadcast. There are going to be some TV broadcast signals in there. Between 88 megahertz and 108 megahertz, you got your FM radio stations. That's going to be all your country, rock, whatever you like to listen to on your car. That's the spectrum that it's in. The 108 to probably around 120 is going to be more aviation. That's going to be your big block of aviation traffic. At the 144, that's where your 2 meter band starts, which is what this thing mainly does. Well, that's half of what it does, really, and I'll get into more of that later. Then you have another big, huge chunk for TV broadcast, and then you have the 1.25 meter ham, or which is, I don't believe is used very much, but I could be wrong about that. After that, we have the ultra high frequencies of 300 megahertz to 3,000 megahertz. Also travel line of sight. Like VHF, these frequencies do not bounce from the ionosphere and are very good for communicating with spacecraft and satellites. The UHF region also includes a broad television band and some public service radio frequencies for police and fire. Some cellular telephone frequencies are UHF, and a popular ham radio band, which is the 20 centimeter band, is in the UHF region or the spectrum, which is what this thing also is really good for. The USS Lexington has a club repeater that operates off of out of the radio room, and they are on the 77 meter band. Then we also have some TV broadcasting on there. Some more aviation at about 1,000 megahertz, and there's a few more ham stations that are on there, but they're not widely used.
One more question, Dale.
Absolutely, ask all the questions you want.
When you're talking about some of these, it sounds like you have a pretty precise frequency for these things here, or wavelengths, should I say rather. How discriminating are there? It's like you said, I think you said it was a 125 or something like that. How close do they have to be in order to be able to use those frequencies?
I mean, there is some margin for error, some drift in the modulations and the thing to that nature, but with digital radios, since most stuff is now going digital and not analog, you can get really dialed into a specific frequency, and you won't have to worry about anything.
Okay.
Does that answer your question?
It does.
Okay. Okay. So radio waves can carry information such as words, sounds, or even pictures between a sending station and a receiving station. Requirement 1 describes some of the different modes by which the information may be encoded into radio waves. Two different modes you may have heard of before include amplitude modulation, or AM, and frequency modulation, or FM. So AM and FM radio, right? No matter which mode is chosen, a radio signal must be generated by a transmitter. This is an example of a transmitter. And to be honest, it looks like a pretty cheap one. A transmitter is a device that produces very rapid back and forth electronics currents called alternating currents, or AC. Yeah, I'm sure if you guys have never done an electric work, you've heard that before. Within an electric circuit called an oscillator. The transmitter combines the oscillator's alternating currents with other electric signals, such as signals from a microphone, to modulate the oscillating currents when modulation occurs. There's your alternating current right there. When modulation occurs, the signals from the microphone are encoded into the alternating currents by changing some characteristic of these currents. For instance, with amplitude modulation, the power of the alternating current it changed to encode the microphone signal. With frequency, that's an oscilloscope right there. With frequency, modulation of the frequency or the alternating current is changed to encode the microphone signal. Either way, the sounds detected by the microphone are carried within the transmitter's electrical alternating currents. So this is an example of the different signals. Morse code here is at the top, AM radio signal, and then the FM radio signal. So that is the original signal right there, the alternating signal, and it is changed into these as you're using them, or as you're modulating them for use. The modulated oscillator currents are set to an amplifier that boosts, there's an amplifier right there, that boosts the power of the currents. These more powerful alternating currents are sent to an antenna, right there, through a feed line or wire cable. The antenna transforms the electrical currents into radio waves and are radiated out into the air and space at the speed of light. So, a radio receiver is a device that detects the transmitted radio waves and turns the signals back into sound. The receiver uses an antenna to pick up the radio waves from the air. With the receiver, the antenna turns any detected radio waves back into alternating electrical currents that flow back and forth in the antenna and into the receiver device through the feed line. The antenna's newly created currents are very weak, so another amplifier, is used to boost their power for the receiver. The receiver has special electronic circuits that reverse the modulation process of the transmitter and it demodulates the signal, getting the original microphone's electrical signals back out of the rapidly alternating currents. The audio electrical signals are sent to a speaker to recreate the sound that went through the microphone of the transmitter. Most modern two-way radios are transceivers. This is a transceiver right here. This is also a transceiver. This is just a receiver. Most modern two-way radios are transceivers, meaning they contain both a transmitter and a receiver together in one package. That way, a single radio is able to bounce or are able to both send and receive radio signals at the push of a button. It's almost like magic, but it's just really cool science and engineering. All right. So this right here, what you're seeing is a basic repeater block diagram. You got the antenna and the feed line, the duplexer, transmitter, receiver, and your controller. So a block diagram like this one shows the main parts of an electronic device like a transmitter, a receiver, or a transceiver. The main parts are represented by simple rectangles or blocks. So it is called a block diagram. For example, one block is a transmitter, and you're able to see where it flows. So you can see the antenna. The signal is going to come into the duplexer, go over to the receiver, then it's going to be fed into the controller, then out into the transmitter, back in the duplexer, and back out into the antenna. Okay, so this is a schematic diagram. Each block in a block diagram can usually be described in much more detail by a schematic diagram. A schematic diagram will show symbols of all the individual electronic components that are connected together to build a part of the radio, or even the entire radio. The schematic diagram will show exactly how the electronic components are connected together. For example, an oscillator circuit that is represented by a block in the block diagram is shown in a schematic diagram. That's not making very much sense. I'm sorry. Well, anyway. For example, what I can tell right by looking at this is number 3 is an LED. It's a light emitting diode. And I know that because of what the shape is. Yes, it is standard among all schematic diagrams. I also know the number 4 is a battery, and number 1 is a resistor. So you can anybody who knows what the symbols mean can tell you exactly what's going on in the picture. And this is actually one of the diagrams used in the licensing requirement for your technician's license. So this is here is one way to show parts of an entire radio station with a block diagram. In many modern integrated transceivers, all the block the block parts are usually encased in a circle to indicate that it's a transceiver. That's not in this picture though. But you can tell that here your antenna's over here with your feed line going into an FC30ATU, which is probably just the receiver. Goes into an amplifier and into the 897D, which has your speaker and your microphone. This is your transceiver right here. Then this down here, there's You can connect these things to your PC and be able to use different different ham services like D-Star and things of that nature. IRLP. Those are all digital realms of the hobby. Okay. A closed circuit. Electricity flows through wires much like water flows through pipes. In a circuit, the flow of electricity must travel around a closed path, which you can see on the left side, that's a closed path. This is called a closed circuit because the flow of current is closed within the path of the circuit. An open circuit is one that has a gap or break in it, such as when a switch is turned off. In an open circuit, the flow cannot continue around the path because the path is interrupted by a gap. As you can see on the right, it's not connected to the bulb anymore. A short circuit is where the current flows in an undesired way. This may occur if two wires are touching an electric circuit when they should not touch at all. This may occur in an electric conductor, such in a way that, or another piece of metal, such as a wire or another piece of metal, accidentally crosses over the circuit and creates a sort of short circuit for the electric current to flow in a different way. Usually what you'll see that in a lot in is when you're working on your car and all of a sudden your electronics stops working, more than likely you got a short circuit in one of your wires. What normally will happen there is the wire is going to just be rubbing as the vehicle cavitates. It's going to strip away some of your insulation and just start touching the frame of your car. And that causes a short circuit and your stuff's not going to work. So here is schematic symbols for common electronics and electrical components. These are the pictures that I was talking about earlier. They're just simple pictures that represent real electric components in a schematic diagram. So over here on the top left, you're going to find resistors. That resists the flow of electricity, electric current in a circuit, which is much like a blockage or narrowing of the water pipe. Let's see, where are they? Okay, the third box down on the left are diodes. It allows circuit current to flow only one direction in a circuit. It's like a one-way water valve or a flat valve. Capacitors, that's the second from the top, stores energy in an electric field that builds up between the two sides of the capacitor when current flows. Inductor, which is the next one over, stores energy in a magnetic field that builds up among coils of wire when current flows. Let's see, battery. Doesn't look like the battery's on here, actually. I showed you the one for the battery earlier. It is that one right here, number 4. And you all know what a battery is, so I'm not going to get into that one.
I don't know what a battery is. I forgot.
Let's see. So transformer should be in here. No. No, it's not. Well, if you look in the... Oh, no, it's right there in the middle. Next to diodes. So transformer changes the volts of electric current from one value to another using magnetic induction between two coils of a wire in the transformer. So usually you're talking about alternating currents to direct currents, or vice versa. Now, transistors, which is the bottom left, acts like a switch or an amplifier. A little electric signal on the one wire into the transistor controls the flow of a much larger current through the other two wires, like a water valve that can vary a strong flow of water in a pipe. Okay, let's see the next one. It's a lamp. And I don't see a lamp on here right now. But I showed you the LED on the other schematic, number 3. Well, you guys know what an LED is. So, let's see. The antenna. Is there an antenna on here? Yes, it's right there in the middle under miscellaneous. The third one from the left in the middle, there is a antenna symbol right there. I've actually never seen it that way. He's usually got the line through the top of it as well. But that is the antenna you use for broadcasting and receiving. And then the last one, that's an important one, is switches, which is going to be the second line, second from the left. These are used to open and close an electrical circuit in order to turn on or off a device or appliance. I know this is a lot, guys. Bear with me. We're at number 6, though.
Out of 9?
Yes, out of 9.
Hey.
And the number 9 is the most fun one. So, electrical safety. Electric shock can kill if enough current flows through a person's body. Lower amounts of electric current can injure a person and be very painful. Be sure to disconnect the power from a radio or any other electronic device before doing any work on it. After a radio is unpowered, the capacitors inside can still store a strong electric charge as described in requirement 5. Be sure that capacitors have plenty of time to discharge before doing any work on the radio, or get them in discharging, or get help in discharging them properly. But that goes with any piece of electrical equipment, not just radios. Pretty much anything that you have with electricity is going to have a capacitor in there. And I know I've done it, and I'm sure anybody else who's opened electronics, I'm sure Dan's done it too. You open it up, you reach in, and you get a little shock. That's because you touch the capacitor. So, depending on the size of the capacitor, depends on the kind of shock you're going to get. Little capacitors, you're just going to get the, ow, I shouldn't do that. Large ones can put you on your back. So, be careful with that. Grounding a circuit means that a path to electricity, neutral, ground voltage, or zero voltage is provided. The earth provides a good electronic ground for radio stations since it can absorb large amounts of electricity. Radio stations will usually have a large wire or metal strap path to a metal rod driven deeply into the earth in order to provide an easy path for electronic currents to go to ground, zero voltage. And that is going... A ground is used also in your house is grounded. There are 3 wires. If you take apart, and I don't suggest doing it, but if you take one of your plugs out of the wall, you unscrew everything, you take it out, you're going to see 3 wires. You're going to see a black one, a white one, and a green one. That green one is a ground. Somewhere outside there, you're going to see a green wire going into the ground, and that's going to be where, if your house is struck with electricity, that is designed to take it into the switchboard, out through that wire and into the ground, and hopefully not destroy everything in the house.
So it's kind of like a lightning rod?
Sort of, yeah. Except the lightning rod takes out the middleman, just takes electricity right from the lightning rod into the ground. Let's see. Alternating current power outlets should be used with a 3-prong plug. That includes a safety ground wire. I just went through that. But you should always use that ground wire because that's going to protect your equipment. So if you take that one off because you're like, well, I only got two plugs in, I only got a 2-hole plug instead of a 3. You take that ground wire off, you lose all the protection of that ground. So don't do that. Just change your plugs. Let's see. Make sure that any radio antennas cannot come close to overhead power lines, even if they fall accidentally. Keep antennas far away from power lines. If your antenna touches the power line while you are in contact with it, or the radio to which it is connected, you could receive a deadly electric shot. The rule is there has to be 10 feet of clearance if that from a power line to your antenna if it should fall. So if you have a 40-foot mast antenna, you have to be at least 50 feet away from that power line. Okay, tower and antenna safety. If you climb an antenna tower, which is what these guys are doing, this is actually a cell tower, I believe. Always wear proper safety equipment, including a climbing harness, properly attached to the tower, safety glasses, and a hard hat. Never climb an antenna tower without another person to help and to observe for safety problems. This second person on the ground should also have a hard hat and safety glasses in case objects are accidentally dropped from above. Whenever working on a tower or near a tower, you always have to wear a hard hat. Lightning can directly hit or indirectly flow into antenna and feed lines. Do not operate your radio with an external antenna during lightning activity in your area, or you could receive a severe or deadly shock. Make sure your external antenna is well grounded to the earth grounding rod. If lightning energy surges into the antenna system, the ground connection will help send much of the lightning energy directly into the earth instead of into your house and radio. Radio emission safety summary. Yeah, there's some radio emissions right there. You never touch a radio antenna while the radio is transmitting. Strong radio signals can cause deep and painful burns if you are touching an antenna while it transmits. So, if you're using this, you're hitting the push to talk key, don't be going like this. You will burn your hand. And the higher the power of your radio, the more severe the burn. Radio frequencies are absorbed by the human body where they are turned into heat. Strong radio emissions can cause dangerous heating of your body tissues. Do not remain close to a powerful transmitting antenna. It's like being inside a microwave. You don't want to do that. So just stay away. Just stay away from antennas unless you know what you're doing and you're doing work on them. Okay, we are going to go ahead and we're going to be watching a short video now. So give me a second to set that up. Since we cannot yes, you have a question?
So pretty much, I have an experience. Remember the last big thunderstorm in Corpus?
No.
Well, there was a big thunderstorm a few weeks ago where the power went out in our area,
Okay.
and yeah, that's pretty much it.
Okay, cool. Thank you.
You're welcome.
All right. So the requirement 7 is to visit a radio station. Obviously, we cannot do that, but there are a lot of hams out there who have made videos, tours of their stations. So that's what we're going to do right now.
Hello everybody, this is Kilo 5.
Can everybody hear it?
Doing an updated video of the Show Me Your Shack. The last video I had was back in 2013.
Can you make it a little bit louder, please?
Oh, there.
Older radios that I was using at the time. And it's been a little bit. I've advanced my knowledge in amateur radio and some of the technology that's being utilized now. So I'll just go through and show you.
Louder still if you can.
I can't. That's it.
Go up.
That's all the way up.
The radios and the devices. This right here is an FTDX 1200. This is my HF machine with a little antenna that's up between the two oak trees outside. I'm able to utilize that radio to talk straight off a battery and anywhere from less than 5 watts to 100 watts. I could talk around the world using this radio here and that microphone. Next, we'll go to local radios. This right here is the FTM 400DR. This is their mobile rig, their base rig. Right now, it's set up into the Wires X mode. You'll see it's connected to my node here, which is a simplex node at this time. It's running simplex. It's in Burleson, and right now it's connected to the Americas link, which there are 60 nodes. Nodes do consist of individual simplex nodes, or they are repeaters. They actually have them connected at this time into repeaters. Next, we'll start with the FTM 100DR. This right here acts as my simplex node transmitter and receiver. This is connected into the back of the WiresX device. That is what does the transmit and receive and the interconnecting with the internet to allow you to talk around the world in digital quality. I chose digital. I don't run it in analog. It just you utilize a lot more of the functionality in the WiresX setup and the Fusion system if you run it in digital. That's the only way you can get the true benefit out of it. This right here is the FT2 DR, which is their HT, their handy talkie. I just have a little duck on it because I'm walking around the house here and I've got the big antenna outside that's transmitting and receiving the signal to the WiresX. So just off of less than 200 milliwatts, I'm using this radio here to pretty much talk around the world. Actually, there's a user right there, VE3 VCF, a little over 1,400 miles away. And VE3 ZZU. Well, he sounds like a computer. I don't know if his audio's got to be changed there. And that was a little bit of the digital. And see right here, it's doing this right here is doing the transmit and receive of the WiresX signal here locally. Right now, I've got it transmitting on the 14655 in digital. The other option that I use to change it to is I transmit to the 444.000 repeater in Cleveland, Texas, which in the WiresX software a little bit later, I'll show you the changes you can make to actually utilize a repeater. If you use this locally on Simplex, I get about maybe 8 to 10 miles coverage all driving around Burleson. It's great for me locally, but when I want to share it out to everybody else, all the other Fusion repeaters in the Johnson County and Boston County area, that's when I point this thing to a repeater, because everybody else that has Fusion systems can utilize the digital and have the fun of talking around the world from their house on their home rig. This right here is the WiresX interface on the computer system as an admin of a node. This is the software that you run. In this field right here, it tells you all the different nodes that are in and out, that are connecting, and which ones are leaving. This interface right here is a chat window. You can actually, you can talk back and forth to the admins that are monitoring. These right here are all the nodes that are connecting at this time. You've got, you'll see repeaters, you'll see individual nodes through here, and up here is the actual people that are talking at this present time. You'll see this is the node, and the second one is actually the device that he's on. Each Yaesu Fusion device has a radio number, and that's what you see popping up with their call sign on it. Here is the room that I connected into, and you can see that it's in digital mode. On this side are all my bookmarks, my favorite rooms to connect into. These are all the individual nodes, so if you want to connect directly to a node, you can from here. And all these down at the bottom are the different rooms. I'll go into my setting that I show that I use for the transceiver to transmit to the repeater. What I end up changing is on the frequency, I change that to 444.000, and then I leave the signal as C4FM. Power, I usually transmit low because I can hit that repeater on 5 watts, so low is 5 watts. And on the offset, you do the +5. And what that does is it changes this to 444.000. The downlink will be 449.000. And then that way, you can actually utilize this and point it to a repeater, and it'll actually, everybody else can have a lot of fun, especially I've got people down around Waco that can hit that repeater that can't hit my simplex node, and and they're able to enjoy the functionality of wires. Well, I guess that's pretty much it. I'll wrap this video up. Again, I'll just give the model numbers that I'm running right now. This is the FTDX 1200. This is the FTM 400DR, the FTM 100DR, and that actually is the body to the 400DR. I've just got it set up in a little temporary rack that's sitting on the bottom. That's the FT2DR HT. And I guess that's it for Show Me Your Shack. This is Kilo 5, Oscar Radio November, saying 7-3, and hope you enjoyed the video this year.
All right. So that is a good example of a Radio Shack. I've actually talked to this guy here locally through a D-Star repeater. He's up in Burlington, Texas, I think, something like that. All right.
And Dale, he has spent no money on that hobby whatsoever, has he?
No, absolutely none. But it's funny that you mentioned that you can actually get secondhand equipment really, really cheap for 80-90% off. There's usually like buy, sell, trade nets that go on over the airwaves, and that's easy way to pick up some good quality secondhand equipment because everybody in the hobby takes care of their stuff. And also, you can get some junk and fix it up. That's half the fun of the hobby as well. Okay, so requirement 8 is that's the end of that. All right. So requirement 8 is actually finding out about 3 career opportunities in radio, picking one, and finding out about the education, training, experience required for the position. So the 3 or the 4 positions are a radio broadcast announcer, an electrical engineer, a broadcast sound engineering technician, and a telecommunications installer and repairer. That's really all you need to run a radio station. So if you guys want to, go ahead and look up those careers and see what might interest you, and get back with us next week about it. That'll be your homework for the week. And let's see, the last requirement is all about amateur radio. I had the choice between amateur radio, broadcast radio, and shortwave listening, and really the only thing I can really do in this format is amateur radio, since I can't take you to a broadcast studio, although I've had training in that as well. And shortwave listening that's really not possible, since you all would have to have your own radios. So amateur radio is also called ham radio. Specific frequencies are set aside by the FCC for amateur radio use, meaning that these frequencies cannot be used for commercial radio purposes like broadcast radio, cell phone services, or other money-making activities. Amateur radio is a fun hobby and a public service for communities where amateur radio may be used to aid firefighters and police during times of emergency. That's actually half of what ham radio is assisting emergency workers in an emergency. Let's see. The FCC established amateur radio service for international goodwill. With some amateur radio frequencies, you can talk around the world to people in other countries. Experimentation, electronic expertise. The amateur radio services encourages the home building of equipment such as antennas and radio circuits, as well as experimentation with new modes of radio communications. A lot of people in this hobby actually build their own transceivers and their whole Radio Shack by hand. They will go in and they will design their own radio. Volunteer service, community communication support, and emergency preparation. As a scout, you can earn your amateur radio license and be prepared to serve your community and radio communication skills. Communications expertise. Amateur radio builds communication skills, both technical and social. I mean, this is the ultimate social distancing, guys. Okay, amateur radio operators or hams do many fun and important things, including radio contests. Ham radio operators compete with one another to make the most radio contacts in a specific time period. Space contacts. Hams can make contact with the International Space Station and talk to amateur radio licensed astronauts, and most, if not all, of them are licensed. Hams can also communicate with other Earthbound hams by having signals relayed by satellites in orbit around the Earth. These links tell you more about amateur radio and space contacts. Portable communications. Many hams enjoy taking their radio station away from home, perhaps to a mountaintop or on a backpacking trip, to communicate from the backcountry and be prepared in case of an accident to get help. Skywarn. Hams report on severe weather observations to the National Weather Service. There's hidden transmitter hunting. It's a game with a radio seeking a hidden transmitter with direction-finding equipment. This popular radio sport is called fox hunting, and some hams combine it with the popular geocaching activity. DX contacts. Hams communicate DX or distant, out-of-the-country radio communications and exchange QSL cards as a record of their contacts. Hams seek awards such as for contacting 100 different countries and other accomplishments on the air. The big one is public service. Hams serve their community with communications for parades and other community events, and by volunteering in special radio organizations that help fire, police, or other emergency response agencies during times of emergency or disaster. So when the hurricane comes, the power is out, ham radio operators step in to fill that communications gap. Jamboree on the Air. Scouting organizations worldwide participate in JOTA each year on the third weekend in October. Scouts and hams team up to communicate with one another over the airwaves around the world. Okay, so unfortunately, because of social distancing, you guys can't actually get to play with this like you're supposed to. But I'm going to make 3 contacts on here to show you guys how it works. The first one, I'm going to connect to a local repeater right out here, probably the Sinton one because that one has the most traffic. So, and before I do that, I need to text my buddy real quick out in California because I'm going to connect to him next. So give me a couple minutes, please. All right. Okay. I can't even show you guys the screen, but this is I'm on the D-Star repeater right now, which is a reflector that a system that is used for digital communication. I'm going to change it. I'll be changing it back to that here in a few minutes. But I have a hotspot, which is my own miniature reflector or my own miniature repeater, so I'm not tying up anybody else's repeater to be able to communicate. Alright, so let's go ahead and get this switched. Okay, so that is Corpus, that's the ISS, Beeville, Refugio, Victoria. Ingleside. Okay. So what I'm going to do is I have it right now tied into the Sinton repeater that is about 7 miles away, I think. 6.5, 7 miles away. And it is a duplex. Repeaters are normally duplex, so they will receive on one frequency and send on another, transmit on another. So first thing you do is you wait and you listen for a few seconds and make sure nobody else is transmitting. And then I'm just going to send my call out there to see if anybody's out there going to respond. KI5 JJS. And we'll see if anybody's listening. KI5, JJS, no contact, clear. So just in case there is somebody listening and they're just ignoring me, they know that I cleared the channel so they can use it. So I'm going to try one more time for a local. I'm going to use the Lex repeater. So that's actually on the 70 centimeter band. The other one was on the 2 meter band. And so we're going to give this one a quick try. KI5 JJS. Of course, they're usually talkative, and now because I'm doing this, they don't want to say a thing. So, yeah, 5 JJS, no contact. I'm clear. All right, so
Yeah, at least you're showing the scouts the real life, because that's always happening.
So I'm going to go ahead and I'm going to switch it back to D-Star. Okay, so here is what it looks like when I'm connected to my own D-Star node. And I'm actually going to show you my dashboard for my personal node, so you guys can take a look at this. So this thing gives you a lot of different information. Up to the top right is the, you know what? I'm going to share the screen instead of just that window. That way you can see my mouse. Okay. So right here is the CPU temp of my repeater. Now it's running on a Pi, Raspberry Pi, so it is actually a computer. It also has a transmitter hat. You can see over here that I am connected to the D-Star network, and to the I got the D-Star mode enabled. It has a lot of other modes you can use, but I only use D-Star because this is a D-Star equipped radio. Not all radios are D-Star equipped. You can see down here that I have this frequency. I have pretty much commandeered as my own. The 438.800 megahertz. That is on the 70 centimeter spectrum, and nobody else is using it, so it's mine. Down here is my call sign. Really cool thing is with D-Star is you can see today. This is the activity that's been on the reflector that I'm on, but because there's a thing called QRZ. So I can actually click on these guys, and it will bring up their information. As long as you are, now you have to be able to, you'll only be logged in, be able to see most of the information. You're going to see what's publicly, but if you want to see other privately stuff, be able to contact them, you'll have to actually sign up, and you can only sign up if you are a registered ham operator. Okay, so I'm going to go ahead and I'm going to try to contact my buddy out in California. So what I'm going to do, since I am specifically targeting one person, I'm going to use his call sign and I'm going to use mine. So here we go. KM6, TAT, KI5, JJS. And you can see in the top, on the top side of the gateway activity, that is me and that I was transmitting. Don't stand me up, buddy. KM6, TAT, KI5, JJS. Can you guys hear the radio? Okay. I'm going to do something real quick. I'm going to unlink it, and then I'm going to link it back up. Maybe I'm just not connected right. So I could do this either through the radio or through my dashboard.
Not linked. KI5JJS. Link to REF004 Bravo. KI5JJS.
All right, I'm going to try one more time. KM6, TAT, KI5, JJS. There we go. Hey, James. I got a group here wishing to hear you talk about a little bit about the hobby and what and any advice you want to give.
Oh boy, you're putting me on the spot. Yeah, so amateur radio is a great hobby. You should definitely get into it, especially if you like electronics. As for advice, study. The first class license level isn't too difficult, but you got to get the basics down. So, yeah. Hopefully that's good enough.
Oh, that was fine, my friend. I thank you very much. Everybody says hi, and I will talk to you later.
Thank you.
Yeah, that was our Scoutmaster saying thank you. Okay, this is KI5 JJS 73. I'm clear.
Hey, 73 Dale. Have a good evening, everybody. This is KM6TAT Clear.
Okay, there we go. He didn't stand me up. All right, so now what I want to do is I want to connect to a different reflector. I'm going to pick one on the other side of the world, and hopefully we'll be able to contact, make a DX contact with somebody on the other side.
If they speak English.
So what I'm going to do is I'm going to look for D-Star reflectors. There's a website on it. I don't remember what it is right now. There it is. And I'm just going to pick one. Let's see. UK Nets Permalink repeaters. London, England. Let's look at the status of it real quick. You have to be a registered, licensed amateur radio. Licensed in amateur radio to be able to get on these reflectors. And of course it's taking forever. Okay. Am I still up, or maybe my internet went down? Okay. Alright. So let's see. So they are at REF005 Alpha. So I'm going to unlink from here.
Not linked.
And you can do the exact same thing in the radio itself. So I'm going to go to REF005. And what was that? It was Alpha. And we're going to link to that.
Link it to REF005 Alpha.
Okay, and now we are linked. What you can do is you can go over here to the reflector in the menu, and we're going to do an echo test just to make sure that they can hear us. So, KI5JJS, testing, testing, 1, 2, 3, 3, 2, 1, test complete.
KI5JJS, testing, testing, 1, 2, 3, 3, 2, 1, test complete.
So, that sounded just fine, so now we know that they'll be able to hear us just fine. So I'm going to go back here to use reflector, and I'm going to listen for a minute, see if anybody's using it, and then try to reach out. KI5JJS. KI5JJS, Portland, Texas.
Well, Dell is 2:18 in London right now in the morning.
Oh, that's fine. There's people up at all sorts of time of day and night using stuff. That's one of the things about looking up the status on the reflectors to see if I can get it to actually go this time. Can you stop hitting my chair, please? It will. The status will actually show you how many people are connected to it at this time. But all right, so we could try another one real quick. This isn't working exactly the way I wanted it to work, but any requests for country?
Ireland.
It's going to be the same time there in Ireland.
I know. You said it doesn't matter.
I also got to find one in Ireland. Oh, there's the Jamboree on the air reflector for D-Star. So if we ever participate in that, and we're using my equipment, that's where we're going to do it.
Well, I propose we do that. You said it was October?
Yeah, third weekend in October.
That'd be kind of fun. I've done that before. We've done it actually as a troop before.
Okay, I'm going to try this Midstar UK in Worcester, United Kingdom, which is REF 036 Alpha. So I'm going to unlink.
Not linked.
Come on. REF 063. I said Alpha, right? Let's see. Oh, 36. Okay. And it could be also that that repeater's also down. That might have been why I couldn't get any information on it.
Linked to REF 036 Alpha.
Okay, we are connected. Connected to Worcester, United Kingdom. Give it a minute or a few seconds. Sometimes there could be like a minute delay between broadcast stations. Ooh, Portugal, Lisbon. I've been there. They speak Spanish. I don't. KI5JJS out of Portland, Texas. KI5JJS out of Portland, Texas. Well, they're not gonna. Apparently, it's just a bad time. So anyway, that's pretty much gonna be it. Of course, it's more fun when you guys actually get to do it yourselves. And as a third party, as long as I'm there, you are able to do it. So.
Well, Dale, once we're able to re-meet again, what we'll do is at a troop meeting, we'll revisit this. We'll spend a half hour or so having some fun with it, so you can show us, more in detail what's going on. And I'd like to, if possible, as a troop, participating in the World Jamboree on the air. That's kind of a fun thing to do.
Okay. Yeah, I mean, that's fine. I have the one radio, but I can reach out to the local club out here to see if we can get a couple more hams out with their mobile setups. Maybe do something right there on the lawn at the scout hut.
Yeah, that'd be a lot of fun. Also, would you repeat what the homework is for next week, please?
Yeah, there's a couple more things I just need to go over, and then yeah, I'll reiterate what the homework is. All right, so Q signals. Q signals are 3-letter shortcuts used on the air. Oh wait. KI5JJS, no contact. I'm clear. Q signals were originally used with Morse code transmissions to help reduce the amount of dits and das transmitted. Q signals are quick and easy and efficient. They are often used by amateur radio operators with phone mode, voice communications also. So, for instance, QSO means an on-air conversation. That is what the goal is to have a QSO. QSL is a knowledge receipt. So, QSL, you hear what they said, and you're like, QSL, I got you. QTH is you're asking for their location. QSY is change of frequency. So you say, let's QSY 437.000, saying we're going to change. Let's change frequency to 437. QRP, low power or reduced power. So you'd use QRP saying, hey, your power is really low. You need to increase it, or you need to lower your power. You're blasting out my eardrums. QRN is noise interference, static, or pixelation on the digital area on the digital front. QRM is interference from another station. In other words, if you're transmitting and you're listening to somebody else transmit, and then all of a sudden you have another station pop in, that's a QRM. They actually, they're either take over the transmission completely, or the interference just makes everything garbled. There are 3 levels of amateur radio licenses. There's technician, general, and extra. I hold a technician's. That is the entry-level licensing requirement, requiring an examination. It covers the basic rules, regulations, and on-air procedures and radio theory. A lot of what's in that test we went over tonight. There is a lot more, but I'd say about half of what we went over tonight is on the technician test. Examination is 35 multiple choice questions selected randomly from a pool of almost 400 total questions. The technician license and actually the pool's only like 250. The technician license allows transmitting on all UHF and VHS amateur frequencies and a small portion of the high HF frequencies. I can actually pull that up for you guys real quick. There's a whole chart. If I can find it, pull it up real quick for you. There we go. Frequency allocations. Oh, there's a pretty chart, and this is all text. Okay. Anyway, sorry. A technician will be able to communicate locally and on repeaters, and also communicate long distances by ionosphere skip when conditions permit on the 10-meter and 6-meter bands. It's the test is easy. I mean, I studied like for a week and was able to pass it 99%. I only missed one question. So if I can do it with just halfway trying, you guys can do it easily. The general is a mid-level license requiring passing of the technician exams first. Oh, and it's only $15 to try. And now they're doing it all. It used to be that you couldn't do it at all over the internet, but now because of the social distancing and COVID-19, you can do it on the internet, through the internet now. That's how I got how I did mine. So you got to pass the technician examination first, and then you take the general has more advanced rules, procedures, and radio theory. Much of the radio theory focuses on the high frequency bands and long distance communications. And the general license will open up more frequencies for you to be able to use. The extra is the highest level licensing, requiring first passing the general examination and another 50 question examination from a question pool of about 700 questions on advanced radio theory. But this license will allow you to transmit on any frequency you want. There is no limitations. Any frequency you can legally use as a ham radio operator. All license examinations are administered by volunteer examiners. All right. Morse code is not even done anymore, so I'm going to go ahead and skip that if that's all right with you guys. And I've already gone over most of that stuff. Okay, so the homework is find out about the career opportunities in radio, in broadcast radio. Pick one and find out about the education, training, and experience required for this profession. And figure out, what you might want to do as a broadcaster profession, and let us know next week. And I think that should be it. Any questions, comments, concerns, or do you just want me to shut the hell up?
Well, not the latter, but yeah, thank you. That was good. Good. So, okay, so what's going to happen is after we go through this next week, you just have to send me a list of the names, and what I'll do is I'll sign them up for the radio merit badge.
I think that was pretty much the entire group.
Well, yeah, I know who it is too. I just wanted to make sure that you were on board with that.
Oh,
also,
yeah.
We can share this with. Is Leanna still there?
No, she had to leave because volleyball practice is over. She'll catch up on the recording.
Yeah,
Addison
so I recorded it.
had to leave as well to eat, and they'll catch up on the recording as well.
Okay, sounds very good then. So we will have the recording after we sign off.
Dale,
Yes.
question, if you had to guesstimate about how much time you're going to need for homework and stuff. I'm trying to put together my presentation for physical fitness merit badge. And so if you had to guess, what do you, how much time do you think? Because I'll try to, do mine with your whatever time you have left over, which you've left.
I don't think we really need that much time. All I'm really looking for from each of the scouts is a position they'd be interested in doing, and
Okay.
what the education, training, and experience is required for it.
Okay, I'll put together my introduction with that in mind.
Yeah.
Thanks.
I'd say that it shouldn't take more than 2 or 3 minutes for each scout to get through it.
Okay.
So about a total of 15 minutes, right?
Yeah, something like that.
Okay, sounds good. Okay. Well, nice night. Everybody keeps themselves very safe and very distanced, and let's not get sick.
One more thing, Dale, well done.
Oh, thank
Yes,
you.
thank you.
Sir, thank you.
I think that's the
Very
most
good,
y'all
thank
have ever heard me talk.
Thank you.
Yeah.
Okay, so I'm going to see if I can. Why don't you see if you can send it back to me?
Yeah,
Let's hope.
I'm going to stop the recording and I'll send it back to you.
Okay.